Expand 1 minus x over 4 all to the power half in ascending powers of x up to and including the term in x squared. State the range of values of x for which your expansion is valid. Hence, by writing x equals 1 in your expansion, show that root 3 is approximately equal to 111 over 64. So I've got the question summarized here. So let's have a look then. So let's use the binomial theorem then. 1 minus x over 4 to the power half is equal to 1 plus nx, so the n is a half, and the x in question is this, minus x over 4, nx plus n minus 1, x squared over 2 factorial plus dot dot dot. That's up to x squared term. So that's equal to then 1 is going to be minus x over 8 is now 2 4s are 8. And then here we've got 3 minuses, so it's another minus. We've got 4 squared, which is 16. And we've got another 4 here. 16 times 4 is 64. And then divide by 2 again is 128. So it's minus x squared, isn't it? Over 128. Plus or minus dot dot dot. There we go. So that's fine. So there's up to x squared. Now the valid range is when this is less than 1. So this will hold for minus x over 4. Modulus of that is less than 1. So that implies that the modulus of x will be less than, the 4 can come out, the minus is dropped, and then you move up the 4 from divide to times. So x is less than 4, or in other words, x lies between 4 and minus 4. There's our valid range. Show that root 3 by letting x equals 1. So x equals 1 gives then. So 1 minus 1 over 4 is 1 minus a quarter is 3 quarters. 3 quarters to the half is equal to 1 minus 1 over 8. So we put x as 1 in. Minus 1 squared, which is 1. So just put 1. Over the 128. And we can put approximately equal to, can't we? Because we've got other terms as well that continue in the series. So here we've got root 3 on top, which we can write as root 3. Underneath we've got 4 to the half, using properties of indices, which is 2. Here we've got 128 over 128, that's 1, minus 8 1/8, 16, isn't it? 16 eighths. 16 over 128, I think. We could tap this in the calculator if you need to. Minus the 1 over 128. So hopefully we get the 111. So 128 takes 16 is 112. Minus 1 is 111 over 128. So that tells us then, if we move the 2 from divide to times, we get root 3 is equal to, and then the 2 comes up, and it will divide the 128 by to make 64, won't it? So root 3 is approximately equal to then 111 over 64.